A very good evening, everybody, and welcome to another one of the daily challenges. This is day number 4 of the September daily challenges, and we are right at our midpoint. We have 7 daily challenges this time around, and day number 4 is upon us. And for those of you who are wondering what's happening, so today's question is based on a previously asked Uber question. Uber also is one of the product companies, and they typically ask like difficult coding questions, similar to like Facebook, Netflix, Amazon, Google, and so on. And what we are doing basically is doing a 7-day daily challenge. Today is day number 4. This time's theme is completely based on product-based companies, and this is day number 4. I'll just quickly, help you out with the rules for those of you joining us the first time. So if you're joining us the first time, basically every day at 6 p.m. we launch a new challenge, and the person to solve the challenge first is at the top of the leaderboard, and things are heating up really quickly on the leaderboard. We're getting a different winner almost every day. The solution is released at 9 p.m. So this video right now is the solution at 9 p.m. and this will go on for about 7 days till up till 30th September, and it's really aimed at anybody who's trying to crack product companies, because in product companies all you need to do is a lot of practice. If you have seen at least 500 questions, previously asked questions, then you can be sure that you are well prepared for any product level company. So that's what we are helping you out with over here. Yeah, so it's completely free of cost, this one. You can just come in, and it's mainly for you to find out your level. If you're not that great, then you should prepare. If you're already good, then it's good practice. I would suggest everybody subscribe to this page, because coming up we also have October daily challenge is going to be launched. So do subscribe to this channel so that you get updates on that. We have a bunch of new placement drives coming up for different companies, and we're going to announce announcements on this channel, so subscribe for that one. And also I'm just going to announce that we are going to launch our own algorithms data structures course, and that will be available pretty soon on the website as well, and a special offer for the first few students. So subscribe on this channel, you will get information about all of those things as well. Write in the comments below if you are interested in an algorithms data structures course, and if you're interested to know more about it, you'll be one of the first to know about it as well. So do put it in the comments below. And yeah, let's get started with our question today. So our question today is actually one of those questions which is pretty straightforward, and in the sense that when you look at the code, you will feel, oh, it's such a small question, because again, in the spirit of like day 1, day 2, and day 3, the solution actually is not a very long solution. It's actually a short 15-20 line solution. Again, it's just if you are able to think about it or not. So I'm going to open the Edyst platform, and you too can also go there by clicking this link above and signing up. Excuse me. The link is also there in the description below. So I'm just opening up the question over here, and let's just have a second to read the question. 1 second. Hold on. Sorry for that. Yeah. So it's called increasing decreasing sequences, and basically we are given a sequence of n integers a1 up until an. We are not given anything about a1 to an, whether it's increasing, whether it's decreasing. Itself is just a bunch of numbers that we are given. And what we have to do is, there is actually multiple steps on this particular question, right? So first things first is, you're supposed to construct a sequence of b and c with length n. So that means they're both parallel to this sequence here, and it should be such that for every integer here, for a1, we should basically, b and c should sum up, every integer in b and c should sum up to that corresponding integer in a. So we'll give an example later on, but so one is that b and c should sum up to a. That's one. The second thing is that the sequence of integers in b have to be non-decreasing. Basically, they have to be either ascending or equal. Two adjacent elements can either be ascending or equal, but they cannot be decreasing. Similarly, c is non-increasing, which means that c is descending. It's either equal or descending. So we have to choose two series b and c such that both of them sum up give a, and b is non-decreasing, c is non-increasing. That's one. And we have to minimize whatever is the maximum element in b and maximum element in c, right? So we have to make it such that the maximum element of b and c is minimum. Okay, so yeah, bunch of stuff happening here. I can understand if you are already confused about what's happening. Okay, so let's take an example and have understand it. So for example, this is the example given to us: 2 minus 1 7 3. I'll actually open this up on Google Sheets just to give you an example of how this works out. And yeah, if you don't understand this, just follow along. This is an array, for example, right? So this is the series that's given to us. This is the series, and what we have to construct are two parallel series, B and C. B has to be such that B is increasing, right, or non-decreasing. Basically, B has to be ascending order and C has to be descending order. So we could have B as an ascending order. Let's say something like, let's say 1, 5, 10, and I don't know, 20. If we keep something like this, then this has to be in descending order, right? So if this is 1, then this one also will have to be 1. And they also both have to sum up to, that's why this is 1, because they both have to sum up to the series A over here 2. So this has to be 1. If this is 5, this has to be -6, because when you sum up both of them, you're going to get -1. If this is 10, then this has to be -3. Now that is not correct, because if this is -6, this became up to like -3, this has to be descending. So for us, C cannot be this, therefore it has to be a little bit higher than 10. In fact, if we keep it something like 20, let's say, then now C could be -13, and we are happy because it's it's descending order, right? So that's there. And here 3, we can't then have 20. We will first of all, it needs to be ascending. So if we keep this 30, this needs to be like -27, right? So this is one way of doing it. Okay, so this is one way of doing it, except that here this 30 is the maximum number for this one, and for C the maximum number is 1, right? Because this is increasing order over here, right? And the decreasing order is here like this, right? So this maximum number is 1, maximum number is 30. What is the maximum of both the maximum numbers? The maximum both the maximum numbers is 30 over there, right? We have to reduce this number. We have to reduce this number 30. So even if I had, let's say, kept 22, this would be -19, right? So now the maximum is 22, and that is lesser than the earlier one. So that's great. In fact, the reason I am keeping this 22 is to make it ascending. If let's say it was 15, right, this would be -8, and this could then be, let's say, something like even if we keep it 16, then this could be -13, right? So to sum up, so now the maximum we are getting is 16, because between 1 and 16 it's still 16, but it's much lesser than the original 30 that we had done, right? So we have to construct a ascending order here in B and descending order in C. Now there are many ways to construct an ascending and descending order. A few examples I have only shown you, that there's many ways of constructing the ascending and descending order. But how do we optimally construct an ascending and descending order over here? That's the major part. Like, how do we optimally construct that? Because if it was just about constructing, then we wouldn't have any issue. We could just go about constructing and we'd find an algorithm for that. But here what we are told is, once you construct these sequences, the maximum number in both of them, so the maximum candidates will be where? There will be one candidate here and one candidate here. The maximum candidates in both of them have to be the minimum possible number, right? So how can I start this series? Let's say if I had, I started this as 1, right? And I made this 5. If I had not made this 5, let's say if I had just made this 2, right? So this would be -4. This is great, okay? And then I could, so this would, this is still 1. And here I could have made it probably 10, right? And, I could have, one second. Yeah, I could have made it 10, is it? Yeah, if I made this 10, then this would be -3. That would not work. If I made this 11, one second. If I made this 11, then this would be -4, right? So that works over here, right? So I could make this 11 and I could keep this -4 because we said descending or equal, right? I could do that, and I could get this to be 11, right? So from 11, I could keep this 11, right? And I would let this one take the negative hit, right? So this one would be -8, and which is fine by us because this one can go descending. So I'll keep this one as 11 because I'm either ascending or equal. So let me keep this as 11 and let me get that here. So how do we, like I just showed you another way of making this up, but how do we optimally construct it? So the hint is in what I just did right now. If we find a negative decrease, right? Our decrease is negative only, but basically in the original series, if we find a negative, what we should do is we should let the descending series take care of the negative. If we find an increase, we should let the ascending series take care of the negative. What does that mean, right? Assume you start at certain number, right? So let's say, for example, instead of these numbers, I start this one over here at 2, right? If I start this as 2, this one has to be 0 because they have to sum up to the series. So our starting element, we are just assuming it to be 2 right now. Okay, it could be many other things, but let's just assume it to be 2. What do we have to do? We have to choose numbers pairs such that they both sum up to -1, then 7, then 3, and make sure that this series is ascending and make sure that this series is descending. Okay, I hope you're following along. Great. Now, if I keep this as 2, now this has decreased, right? I cannot decrease this, but I would say let's not even increase it. Okay, let's keep it to 2, right? And let this negative decrease that has happened, let that be handled by this sequence. So the decrease has happened by 1, right? The decrease has not happened by 1, sorry, it's happened by 3. You have done 2 and you've gone to -1. So 2 minus 1 is 3. We have decreased by 3. Let that 3 be handled here, right? So let it be handled here. And this is fine with us because this could be decreasing. We are okay with that. This, let it be same. Now we have an increase, and the increase is of 8. Okay. So we have an increase of 8. Let that increase be handled over here. So the decrease remains same because we are not doing anything, but the increase, let it be handled over here. So we got an increase to 10 and this became -3. Right. Now we again got a decrease. So for a decrease, let this be as it is and let that be handled by the below one, which this would become -7. Right. Because we got a decrease of 4. So we let that decrease come over here. Right. So overall, what's the maximum number here? 10. The overall maximum number here is 0, right? And so therefore, the maximum of this is 10. Between 0 and 10, the maximum is 10. Can we reduce this even further? Can we bring it down even further? From 10, can we bring it down even further, right? Let's say, okay, if I started at 1, would this be any better? Okay, this would be 1. Let me just remove all of this. If I started this as 1, how much of a decrease has there been here? Again, -3 decrease. We don't let this handle the decrease. We keep it as 1 and this one becomes -2. Okay. There's an increase of 8. So we let this one handle it. This becomes 9 and this one remains -2. Great. There's a decrease of -4. So what we're going to do is let this remain as it is. And this one from -2 goes to -6. Now the maximum number I have got is 9 and 1. And so that is lesser than our earlier 10, right? So if you're noticing what's happening is, if we follow this strategy of let the increase be handled by the ascending sequence, because that is the only one that's allowed to increase. Let the decrease be handled by the descending sequence. So let that be the only one that's allowed to, because that's the only one allowed to decrease. If we do this sort of, responsibility sharing, then the only thing I need to take care of is what is the starting number over here, right? The starting number will tell me, and even in that, see, look at it this way. If I'm starting at 1, if there's any decrease, then this will remain the same. If there are any increases, then this will eventually increase to that level. For example, 2, how much it decreased over here, then from here to here it increased, right? How much was it increase? It was an increase of 8. Therefore, if I start at 1 and if I go through the entire thing, I will get an overall increase of 8 there, which I got 9, right? How many decreases are there? There's a decrease of -3 and there's a decrease of -3 again. So sorry, there's a decrease of -4, right? So overall there's a decrease of -3 plus decrease of -4, which is decrease of -7. That's why when I started at 1, I ended up at -6 because 1 minus 7 is -6. So because we are letting the decreases being handled by the descending array and the increases being handled by the ascending array. Okay, I'll show you another example. Let's the example we have over here, that is -9, -10, -9, -6, 5, 4. Again, there's no order to this, but what we're saying is, okay, assume I started at, let's say 1, right? This has to start at -10, right? Because they will sum up to give -9. Now there's a decrease. If there's a decrease, I let this be 1 in itself. That is great. If and here I will say it is -11, right? Now there's an increase of 1, so I let that come here. This becomes 2, right? And this remains -11. There's again an increase of 3, so what I will do is I will make this 5, and this again remains -11. There's an increase of, how much would that be? 11, so this will become 16, and this again remains -11, right? Because sum of 16 plus -11 is 5, and from 5 to 4 there's a decrease, so I will let this be 16 and I'll let this be handled by this, right? So here if I go this way, this 1 will finally increase to 16 and -10 will finally decrease to -12. Now we don't have a problem with what it decreases to, right? Let it decrease to whatever it is. We are concerned about the maximum number. The maximum number will be the starting point here, and it will be the final increase till what it increases here. So this 1 finally increases to 16. How did this 1 increase to 16? It's because there was an increase of 1 over here, there was an increase of 3 over here, so 1 plus 3 4, already an increase of 4, and there was an increase of 11 over here, so there's a total increase of 15, right? Increase of 1 over here, increase of 3 over here 4, and increase of 11 over here 15, and 1 increased by 15 to 16, right? So now we know for sure that the maximum possible in B will be the sum of all of the increases. Whatever I start with in B, the sum of all of the increases will finally lead me to the maximum in B, and the maximum in C will just be the first number over here, and therefore we have to choose our first number wisely such that it doesn't increase to too big a number, and also it doesn't put this number down too much as well, right? That's what we are trying to do over here. Okay, I'll formalize this on our slides, right? And so what I'll do is let's just, you know, okay, so I'll just come back and just formalize this on our slide over here, right? So give me a minute. Okay, so this is what we decided so far. There are so many moving parts. How do we construct a sequence? We have to say B has to be ascending, C has to be descending. So what did we do? We said let B handle the increases. Sorry for that. Yeah. Let B handle the increases. Let C handle the decreases, right? That's what we are going to do. We are going to focus on that. Let B handle the increases, let C handle the decreases. So we are good with that. If we do it this way, then what will happen? Let's see our approach, right? This is what you're doing. What about max B and max C? Well, we know that B, that's the maximum number, is going to be last element in B because it's increasing, and C, first element in C, right? We know that max of C is going to be this and max of B is going to be this. Okay, and let's take some more thoughts. Let's call this number some num over here, right? So what will the max element C be, right? So sorry, not this num, one second. Let's say you know, we initially chose B of 0 to be equal to some num, like we were choosing 1, we were choosing 2, it could be anything. So max element, which is the last element in B, will be num plus something because it's an increasing, right? So it will be num plus something. What is that? I'll just come to that. And first element in C will be nothing but A of 0. Why A of 0? That's of series, right? So A of 0 minus num, right? Because C of 0 plus B of 0 will give you A of 0. Therefore, A of 0 minus B of 0 will give you C of 0. And A of 0 is whatever it is minus num. This is known to us. A of 0 is known to us. It's given in the question. Num is not known to us, right? So let's figure out what num should be. And what will be the maximum element in B? Num plus sum of all increases, right? This is what it will be. Like how 1 rose all the way to 16, right? And in the previous one, minus 2 always rose to, I think, 2 always rose to something else. So num plus all, the sum of all increases will be the maximum element of B. And for C, it will be A0 minus num, right? That's what we are going to get over here, right? Okay, so this is going to be the max element here, and this max C is going to be this over here. That is, first element in C is just going to be this value minus, you know, this thing, right? Okay, great. So now what we have is, this is sum of all increases, which we also know. We know this value over here, right? We know the value sum of all increases because we are given the array, right? So I'll just copy this one second. Let's just get a new slide. Okay, so we know that the max element of B is the last element in B, which is num plus sum of all increases, and max element in C is A0 minus num. Okay, great. So we know this. Let's say sum of all increases is equal to some value called diff. Okay, I'm just calling it diff. So what we are saying is num plus diff, right, is there. This is max B, right, and max C is A0 minus num, right? This is the value that's given to us, correct? Which means to say that this is, let's say, the answer is one of these two values, right? It will be either num plus diff or A0 minus num, whichever is higher, right? So the answer is this, maximum of this or this, right? Num plus diff or A0 minus num, right? Where this num value keeps changing. Let me, instead of calling it num, let me call it x, right? Or just keep it as num, right? This num value we don't know. We ever continues to experiment with this num value, right? We weren't sure of what this num value is going to be. And again, this might be a little bit confusing, so I'll just go back to the slides to this and just show you. Here the num value is 1. Based on this num value, because the increases, the diff we have is to minus 1 increasing to 7 is plus 8. So this 1 increased to 9 over here, right? And this other value is 1 because 2 minus 1 is equal to 1, right? I've also written a formula to automate this, so I'll just show this to you as well. Just copy this formula over here, right? 1 second. Oh, hold on a second. Yeah. Okay, great. So now imagine if this started with 2, right? What you have is, 1 second, this. Yeah. So you have this, right? What you're getting is, if this started with 2, the maximum number you'll get is 10, and the maximum number you'll get here is 0, obviously, right? If this started with 1, I would get 9 here, and the maximum number would be 1 over here. If this started with 0, I would get 2 here, maximum number here would be 8, maximum number here would be 2, okay? Let's go even further. If this started with minus 1, then this would be 3, this would be increased all the way to 7, right? And this would decrease all the way to minus 4. So now the maximum number you have is 7, right? This changing of numbers here, right? So this changing of numbers that you see over here, this is the value of num I'm talking about. Whatever the num is, this will be a of 0 minus num, right? So this c value will be a of 0 minus num, and this value over here will be num plus sum of the differences, right? So whatever is the num plus sum of the differences will get you 7. Sum of difference here is just 8, right? Because that's the only increase we have. Minus 1 to 7 would be 8. So minus 1 plus 8 will give us 7 over here. So that's what I'm talking about, guys, when I show you this equation. That is, we are taking the num plus all of the differences, or a0 minus num, whichever is maximum. a0 minus num is the C sequence, and num plus diff is the B sequence, right? This is the maximum number in the B sequence, right? Now, if both of these have to be equal, right, or rather we have to find a way in which this entire thing has to come minimized, right? So if you have two numbers and you have to minimize them, let's say you have 1 and 10, right? The maximum of them would be 10. What you will try to do is try to reduce the maximum number, right? So you'll try to say, okay, instead of 1 and 10, make it like 2 and 9. So now you're trying to reduce the maximum number, right? So you have to continuously try to reduce the maximum number, but not too much, because that will spill over into the other one, right? I'll show you this also as an example. So here we did minus 1, so we got 7 over here, but we got 3 here. Notice that while this increases, while this is decreasing, this is now starting to increase, right? If I made this minus 2, this became 4, this became 6. If I made this minus 3, this became 5, this became 5. Now if I made this minus 4, this becomes 4, this became 6. So the maximum value I'm able to come to, or rather the minimum value of the maximums, is 5, right? So if I keep going further on this route, I will get, if I do minus 5, that goes 3, this becomes 7, and we are again back to when we started with 0 over here, it was 8. When we started with minus 1, we got 7 over there, we got 3 over here. The idea is the difference between these two has to reduce so much, it has to almost become 0. That means the difference between these two has to become 0, or as close to 0 as possible. That is when we have minimized these maximum numbers, right? So if, let's say for example, I made this minus 3, this one becomes 5, this one becomes 5. You cannot minimize the numbers any further. One of them will increase, one of them will decrease, right? So it's no longer possible to minimize the maximum number over here, which means those two both maximums, if it is possible to get them equal, try your best to get them to become the equal number, right? So that's what we have to do. And so if you want to say this num plus diff should be equal to num plus diff should become equal to a0 minus num, right? Which means that num is equal to a0 minus diff, right? Sorry, okay, num is equal to a0 minus diff, and this entire thing divided by 2, right? Divide by 2, but obviously take, if it's an odd number, take the higher number from this one, right? So take the higher number from this one, right? That's what you're supposed to do over here, right? So like for example, if it's an odd number like 11 by 2 would be what, 5, but the other number would become 6, so you prefer the other number, right? That's what you are going to do over here, okay? All right, so that's what it becomes finally. This is the num, right? And this, if you got this num over here, 1 second, have I got this correctly? Num over here, this becomes num plus difference, and a0, yeah, so this is the num over here, and then the answer becomes whatever is the maximum. Either you chose this as the best num possible, right? You chose this one as the best num possible, one of them. So if you, yeah, you chose this as the best num possible, substitute it over here, and that will be your answer, right? This number, just substitute here, you're going to get that as the answer. In fact, if you do substitute this over here, what you're going to get is, you're actually going to get that only. You substitute a0 minus diff by 2 over here in this num, let's say, what are you going to get? A0 by 2 minus diff by 2 plus diff by 2, which is nothing but a0 plus diff by 2. That is what you're going to get, right? So if num is this, that means that the answer, num plus difference, is nothing but so answer is equal to max of a0 plus diff, this entire thing by 2, right? Entire thing by 2, or a0 minus, yeah, so it again be a0 plus diff by 2, right? Again, so it's basically, the answer is this, the answer is a0 plus diff by 2. That's what the answer comes to finally, and take the bigger number over there. That's what you're trying to say. So num is equal to this, you substitute it there, you'll get a0 plus diff by 2, and take the bigger number out of those two over there, right? That's all you need to do, and you'll get the answer. So finally, boiling down everything, it just becomes a simple mathematical equation, and you just have to find the sum of all of the increases. And once you found the sum of all the increases, which is stored in diff, then you just do a0 plus diff, the entire thing, divide by 2, and make sure that you take the bigger number if it's an odd number, right? So you do this, and you can do that, right? You can get the bigger number of the odd number, right? Okay. If it's an even number, then, like for example, the sum of these two will be 10, so 10 by 2 is 5, so that's easy to do. But if, let's say, the sum of these two was 9, then you'll pick 5 because it will be 5 and 4 over there, right? So that's what you do. So let's go to the question right now and try to understand. And again, try to use pen and paper for this one. I'll just remove this. Try to use your pen and paper and try to solve this. You will also find this as simple. Now, I'm again going to use Python because it's fairly straightforward in any programming language, because you just have to take like a sum of the array. That's mainly it. But you know, you can do it in any other languages. So I'll just put this t is equal to int input, because the first line of test case, first line is the number of test cases, right? And then you have to get for each test case the size of the array. So you got here this thing, n is equal to int input. Sorry, first is, these are the number of test cases, right? So for case in range t, what we're going to do is n is equal to int input, right? That's the size of the array. ARR is equal to list map int input dot split. This is the array, this is the a array over here, right? Okay. All right, so we got the a array. Now what we want to do is get the diffs, right? All right, so we actually don't have to construct a b and c. If you look at the final thing, b and c, we don't really have to construct. So we have to get the diffs. So we'll go for I in range 1 till length of ARR, right? We're going to go till there. Let's say diff is equal to 0, and what we say is, if ARR I is greater than ARR I minus 1, that means it's increasing, we say diff is equal to diff plus ARR I. So this is the first thing that we did. We got all of the difference sums over here, right? That's what we did over here. We got the different sums. Great. Oh wait, yeah, if ARR I is greater than ARR I minus 1. If it's not, then we don't consider that, right? So that's what we're doing over here. Then what did we say? The answer is equal to diff, 1 second, yeah, so the answer is equal to diff plus ARR of 0 divided by 2, right? That's what we're saying. So this entire thing divided by 2, and in case this diff plus ARR 0 was odd, we have to take you know, the bigger number. So what we're saying is answer is equal to max of, you either take answer, right, or you take this diff plus ARR 0 minus answer, right? So it's basically if I got 5 and the sum was 11, I will take either 5 or 11 minus 5, which is 6. So that's what you're taking over here, and you just have to print the answer over here, right? Let's run it and see. Have we made any mistakes? Yeah, we've definitely made a mistake over here. So we should be minus 12. Sorry, it should be 3, but we're giving minus 12. Interesting. Why are we giving that? ARRI greater than ARRI minus 1. Diff is equal to diff plus ARRI. Diff is equal to 0 here. Okay. Greater than ARRI minus 1. Diff is equal to diff plus this. Answer is equal to diff plus, is that what we agreed on? Diff plus ARR 0 by 2. Yes. And answer is equal to max of either you take diff of ARR 0 by 2 or you say diff of ARR is diff plus ARR 0 minus answer, right? Okay, we made some mistake somewhere. Yeah, we have to take only the increases. So again, ARR of I minus 1, right? We have to take only the increases. We don't have to actually take the entire array value. We're just saying we have to take the increase in the value, right? So let's just run this again. Now it works here. Let me just submit and check. And great, it passes all the test cases. So again, one of those questions, it's pretty straightforward if you know how to do it. So obviously it's not straightforward, and it's a 15-line code. It's not even a very long code. It's just a 15-line code, and it was more like a maths question rather than a coding question. But it's also coding question because you need to know arrays, and there's a lot of logic you could have just used in terms of understanding where the maximum number is, where the minimum number is, right? I hope none of you are confused about this part, which is this what actually happened here. It's basically, again, we are saying that the maximum number is the max. If you have to divide an odd number into two numbers such that the bigger of the two numbers is as less as possible, this is how you would do it. So that's what we are doing over here. I hope you followed along about how we constructed the B series and how we constructed the C series. For more such challenges, and if you want to know more about the September daily challenges, you can come here and join in this link. That's the link mentioned here, or reach out to us at team@edyst.com for any other queries. Again, a reminder to everyone that to subscribe to this channel if you want more such tutorials. I hope you liked it. If you enjoyed it, do let us know in the comments. Your encouragement means a lot to us. And tomorrow, day 5, another question. I believe it's from Google. So stay tuned for that, and wishing you all the best for that one. And yes, more important announcements to come in. So don't forget, if you are interested to learn these kind of algorithms and data structures, we are launching a full-fledged course. Do put it in the comments below that if you're interested in something like that, and you'll be one of the first to know. And obviously the first few students will get a special offer as well. So thanks everybody for joining in today. This was the question called increasing decreasing sequences asked by Uber, a similar question to what Uber has asked. I hope you all found it useful. Thanks everyone for joining, and I'll see you all next time. All the best.